Welcome back, guys. Today we are digging through this absolute disaster of a scrap pile to find gold. And by gold, I mean these old, rusty car shock absorbers. Time to see if we can turn junk into a premium blade. Hit that subscribe button right now because things are about to get hot. Time to break out the angle grinder and slice away the outer housing. Look at those beautiful, blinding sparks fly. We need to cut through this thin casing wall carefully so we don't notch the steel rod hidden inside. With the outer shell sliced open, we can finally pry out the core piston rod. This inner shaft is made of high-tensile carbon steel, perfect for holding a razor edge. We secure the extracted rod into the vise and use a heavy-duty cut-off wheel to clean up the ends. Precision here is key. We need clean, unadulterated steel cores if this pattern welding experiment is going to work. Now we slice this solid steel rod into 7 short, completely identical cylinders. Why 7? Because packing them into a tight cluster creates a perfect hexagon shape, with one central rod right in the middle. Slicing through thick steel rods always takes a hot minute, but the angle grinder does the heavy lifting. Laying out our 7 little steel soldiers on the bench. Now we need to lock them into a tight bundle so they don't roll away in the forge. I'm grabbing my welding mask and heavy leather gloves to secure them. Using the MIG welder, I'm tacking the ends of the cylinders together so they don't shift. Then, I weld a heavy threaded bolt to the top of the bundle to serve as a handle, so I don't roast my fingers later. Straight into the gas forge it goes. We need to crank the heat up to around 2300 degrees Fahrenheit to get this bundle glowing bright lemon yellow. We want it fully soaked with heat right to the absolute core. We sprinkle sodium tetraborate, commonly known as borax flux, generously over the hot steel. It melts into a protective glassy layer that eats away surface iron oxides, allowing a perfect solid-state diffusion weld under pressure. We move the sizzling hot bundle over to our hydraulic forging press. This beast applies tons of direct force, compressing the 7 individual rods into a single unified billet. We squeeze it, flip it 90 degrees, and crush it again until it's solid. Now that the bundle is fused, we switch to the power hammer to draw it out into a long, flat bar. The rapid rhythmic impacts stretch the steel grains out nicely, flattening this thick chunk down evenly. We set our freshly forged bar on the anvil to cool down slowly. Look at that gorgeous dark texture. Once it's cool enough to handle, it's time for some rough surface cleanup to check our work. Fire up the angle grinder with a coarse grinding wheel. We are grinding away all that crusty forged scale to reveal the clean, bright steel underneath, checking for any delamination or hidden cold shuts. Let's break out the tape measure and a marker. We are measuring out the bar and marking it into 5 equal sections. We are going to cut these up and stack them together for a more complex Damascus layer pattern. Back to the cutoff wheel to slice our bar into 5 identical blocks. Slicing through this newly dense, forged steel takes a bit more effort, but a sharp wheel cuts right through. Watch your fingers. These pieces are blazing hot. We arrange the 5 blocks into a neat stack. Before welding them up, we ensure the flat faces are completely clean. Any trapped scale between these layers will create nasty voids in our final blade profile. I'm clamping the stack tight and using the welder to seal all the seams to keep out oxygen during the next heat. Finally, I weld a sturdy rebar handle to the end for maximum control when handling this brick. Back into the belly of the forge for round 2 of high heat cooking. We slide the heavy stack into the flames to let it slowly come up to that sweet orange-yellow forge welding temperature. Once the multi-layer stack hits that critical temperature, we bring it back to the press. The machine crushes the 5 distinct layers into a single high-density billet block. You can see the extra scale exploding off. We alternate pressing the flats and the sides to maintain a perfect rectangular geometry. Blacksmith life hack: always keep your dies clean to avoid pressing unwanted dents into your pristine billet stack. Back to our trusty power hammer. Now we are drawing out this new multi-layer block into a massive, wide, flat plate. This is going to be the main blank for our knife, shaping thickness and width simultaneously. We continue to hammer the bar, refining the straightness, and forging out a nice, clean taper towards what will eventually be the tip of our blade. It's a continuous process of adjusting your tongs. Working the steel at the right temperature is critical. If it gets too dull or cold, hammering it can cause micro fractures along the weld lines, turning our custom blade into a pile of useless metal shards. Giving the blade blank one final pass under the power hammer to make sure it's dead straight and completely uniform in thickness across the entire length. Any warp or wave introduced here will make grinding a nightmare later on. We stick the flattened bar back into the forge for one quick heat cycle to relieve any internal stresses. This simple step prevents the steel from warping or cracking during the upcoming profile work. We let the forged plate cool down, and then it's back to the workbench for a heavy session of rough grinding. Using an angle grinder, we are smoothing out the rough hammered texture across the flats. This rough grinding stage is where you clean up the profile and see the true quality of your forge welds. We clean both sides of the plate until the steel looks like a pristine canvas for our design. Time to get artistic. Using a black marker, I'm sketching an aggressive Bowie-style profile directly onto the steel, complete with a sweeping belly, a sharp clip point, and deep ergonomic finger choils on the handle. Now we lock the blank securely into the vise and fire up the angle grinder with a heavy-duty cutting disc. We're going to carefully follow our marked lines to profile the rough shape of our new monster blade. Throwing plenty of sparks as we slice through the forged high-carbon steel. Take your time on the curves. Forcing the cutting wheel can cause it to bind and shatter, which is an experience we definitely want to avoid. To cut out the complex finger grooves on the handle, I'm making a series of relief cuts straight down to the marker line. This classic blacksmith trick makes it much easier to grind away the small segments of metal. With the relief cuts made, I use a grinding wheel to clear out the excess material from the finger slots. This rough shaping establishes the ergonomic handle profile before we move to finer, more precise sculpting tools. Now we swap to a high-speed die grinder with a coarse carbide burr. This thing cuts through steel like butter. I'm carefully radiusing those finger grooves because nothing ruins a hard day of chopping faster than a handle that bites back. Taking extra care on the fine curves and checking the symmetry. This tool throws tiny, incredibly sharp steel splinters, so make sure your shop apron is tied tight unless you want your shirt permanently bedazzled with metal shavings. Goggles off. Time to look human again. The profile is dialed in, so now we lay the blade on the bench to mark our pin locations on the tang. A couple of quick dabs with the marker, and we're ready for some high-pressure penetration. Over at the drill press, we clamp the tang down. We are drilling our pinholes while the steel is still annealed and soft. Try doing this after the heat treat, and you'll do nothing but melt an expensive drill bit into smooth chrome scrap. Sinking multiple holes through the handle section. Not only are these for our solid brass pins, but they also serve as skeletonization holes to shed some weight and balance the massive forward belly of this blade. Now comes the most therapeutic and stressful part of knife making, rough grinding the primary bevels. I'm using a fresh, aggressive grinding disc to establish our initial cutting geometry. We're establishing the plunge line right near the choil and tapering the thickness down toward the edge. I'm leaving the actual cutting edge about 1 millimeter thick for now so it doesn't warp or overheat during the quench. We slide the blade into the forge to bring it up to its critical temperature, roughly 1500 degrees Fahrenheit. We want a perfectly uniform cherry red color across the entire steel body. No hot spots allowed. Here we go! Out of the forge and straight into the used engine oil bath. Boom! Instant fireball. This sudden thermal shock locks the carbon structure into a super hard, brittle state called martensite. Back to the angle grinder with a fine sanding pad to strip off the post-quench oxidation layer. We need to polish the surface back to bright, bare metal so the chemical etching solution can do its job properly later. I'm spraying a generous amount of surface cleaner and diving into manual hand sanding with a hard sanding block. This eliminates any minor scratches and ensures the flats are perfectly true before the big reveal. Now for the absolute best part of the entire build. We submerge the clean blade into a deep tube of ferric chloride acid. This solution reacts with the different carbon contents in the steel, eating away the layers at different rates. We neutralize the acid and scrub the blade down with ultra-fine grit sandpaper underwater. This hand-rubbed finish pops the bright nickel steel layers while leaving the high carbon layers dark and shadowy. Blade is looking wicked. Now we step over to our lumber stash to find the perfect handles. I'm hunting through these exotic hardwood blocks to find a pair with beautiful grain structure that matches the premium look of our Damascus steel. We lay our selected hardwood scales flat on the workbench and position the blade's handle section directly over them to map out our matching geometry. Using a mechanical pencil, I'm tracing the exact contour of our steel handle and finger grooves onto the wood blocks. This gives us a precise cutting template for the bandsaw. Sinking our drill bit into the second wooden handle scale to finalize our alignment holes. Tracing out the exact contours of the ergonomic finger choils so we have a perfect cutting path. Fire up the bandsaw. We are carefully tracing our marker lines to rough cut the handle shapes. Take it nice and steady through these corners. Dense exotic hardwood can easily bind up or snap a thin bandsaw blade if you try to force it through the curves too fast. Let the machine do the work. Time for the messy part, mixing up some high-strength 2-part epoxy resin. You want a perfect 1-to-1 ratio for maximum chemical bonding. Slathering the mixed epoxy generously across the interfaces of both scales. This ensures an airtight, moisture-proof seal against the steel tang. Pressing our solid brass pins through the wood, sliding on the custom blade, and capping it off with the top scale. A beautiful, sticky handle sandwich. Over to the anvil for some percussive persuasion. We use a ball peen hammer to flare out the brass pins, locking the handle mechanically for life. Back in the vise, I'm using a small sanding drum on the die grinder to meticulously carve and round out the wood inside those tight finger grooves. Wood sands down exponentially faster than steel, so keep a light touch here unless you want to accidentally redesign your entire grip. Swapping to the angle grinder fitted with a fine flap disc to bring the hardwood scales perfectly flush with the exposed steel tang of our blade. Knocking down all those blocky, sharp corners to transform these raw wooden blocks into a sleek, comfortable handle that fits the hand like a glove. Time to pay your dues with some manual labor, hand sanding the wood handle with fine grit sandpaper to eliminate every single tooling mark. Getting deep into the contours of those finger grooves ensures a flawless, ultra-smooth satin finish that screams premium craftsmanship. The absolute most satisfying moment of the build, rubbing on a protective oil finish. Watch that natural grain pattern instantly explode. Now we give this monster its teeth, pulling the edge across the mini belt sander to grind a crisp, uniform secondary bevel and establish the final apex. Refining the edge on a leather strop loaded with polishing compound. This pulls off any microscopic burr, leaving the blade terrifyingly sharp. First test of the day, slicing through wood like it's soft butter. The edge holds its structural integrity beautifully with no rolling. Testing the razor finish on my arm hair, completely bald in a single pass. That is what I call scary sharp. The ultimate test of fine edge geometry, slicing a soft tomato. It falls right through the skin with zero resistance, just perfect paper-thin slices. Let's see how it handles a heavy chopping blow outside. Felled that log in one swing. The high-tensile core steel is an absolute beast. And there it is, resting on the anvil. From greasy, abandoned automotive shock absorbers to a premium, custom Damascus Bowie knife. Look at that incredible contrast and pattern from the combined steel rods, paired perfectly with our custom ergonomic hardwood handle. If you want to see more insane scrap metal transformations, hit subscribe, leave a comment on what to build next, and share this video. See ya!